Oke, terima kasih sekali atas penantiannya ya, kesabaran atas penantiannya. Kita akan mulai perkuliahan mikroprosesor dengan judul pengenalan program ya, mikroprosesor. Dan sekali lagi saya ingatkan untuk teman-teman yang yang tidak familiar dengan bahasa Inggris, minta tolong teman-teman menggunakan segala daya dan upaya untuk dapat memahaminya, karena perkuliahan pada kali ini kita menggunakan Inggris sebagai bahasa pengantarnya, seperti itu. Okay, let's start our discussion here. Okay, this is the introductory of microprocessor, which is I combined with the other subjects, which is how to program microprocessor 8085. This lecture will little bit not what we call not maybe not sufficient yet, but it is okay when we are trying to split the topics into several parts. So I hope you guys understand what I'm saying, and please stay tuned on the FLearn for the further information. And it is related with what is it? With the person that not yet been registered on FLearn. I hope you guys don't know. Maybe you can try to contact the administrator of the FLearn, or maybe you can contact me and I can maybe call the administration for you in order to be registered in FLearn. Okay, let's continue our discussion about the intro of programming microprocessor using 8085. So the idea of this lecture is basically how to use assembly language and how to process it. So the truth is, almost every line source code is in assembly language. Source code program translate directly into the machine instruction for the particular processor. As you can see in the page here, in the slide here, you can see the assembly language just looks like human language. Maybe it is bit understanding, or maybe we call it as information when you read the language. And then there is an assembler or linker, which is used as a processing unit in order to translate your language, assembly language, into the machine language. So whatever language that you use to program the computer, there is always an assembler or linker which is used as a translator. What is translator? Translator means a process or a system that it is used for the translating activities. So your word will be what we call as a compare. Yeah, compared in the truth table, looks like. And then the word means something which is always in the form of the binary code. Remember that the machine actually able to run something using the binary code. So the machine language is basically bunch of binary code which is linked together and understand together in the machine ways, so then the machine able to to the processing something, which is input, which is data in the form of binary code. So, what is the assembler? So, it is actually the simple software tool designed to simplify the task of writing computer program, and it is enable you to make the recognizable command to command the computer or machine. So what the assembler does, there is a source programmer file, as I told you previously, and then goes to in the assembler program, which is translator that described in the previous slide, and it will create three files. First is object files, second is program listing, third is cross-reference listings. Later on we will see what exactly behind of those three things. So, first thing first, we need a source code and then translating. Of course, symbolic code, which is source code, is actually the symbolic code and executed at the microprocessors. So, what is an object code then? You can access or load the program in some way, develop program in some way for testing and debugging. This allows you to test the program before the prototyping application system is fully developed. So the other one, relocate the format. This is the freeze for the programmer who managing the program into smaller separated assembly modules. Thus, such modules are easier to code and test. So the next one is the program listing. It is provide permanent record both source code or program and the object code. The assembler also provide diagnostic messages for common programming errors in the program listing. Example, if you specify 16-bit value for instruction that is needed into 8-bit instruction, the assemblers tell you that your value exceeds the permissible range. So the other is symbol cross-reference listing. This is another type of diagnostic tools like program listing provider that I described in the previous slide. Aim is for pointing each instruction that refers to the symbol data reference. So these are the steppings in the assembly language coding, and the other one is PLM machine coding. So the first thing first, we need the we need load register with the number of characters to be moved, and then after load is already done, then you do the load register pair P with the address of source. This is the FLT1 function number one. So load register pair D with the address of destination. Even though you are not yet not yet understand what is going on here, please remain calm and please notice first, and then I will give you in the moment something which is related with the understanding of how the program works in the part 2, of course. This part 1 actually introductory for you to make you familiar with the programming 8085 or maybe 8086. Okay, let me continue. After FLT2 already done, then you need to load accumulator with 1 byte from the source file and then move characters from accumulator to destination file. Okay, And then after that, increment source address, increment destination address. These two are necessary because it is related with the what happened in the next session. And then after that, decrement characters count. Is it the characters count equals to 0? If it is not, then goes back to the load accumulator with 1 byte from the source file. And if it is yes, then we'll take to the continue session. So these are the, for an example of a assembly program to make the, what is it, decrement from, for example, from something to something until it is 0. If it is not yet 0, then the decrement goes on. If it is already 0, then the decrement goes off. And after it is fulfilled with the aim, with the goal is being fulfilled, and then goes to the other program. See the word continue here, meaning that the word continue here is the next session of the program. So we can use PLM coding, which is called move, as FLT and FLT1. So the bonds guys here being simplified with a simple instruction line here. So what you got then? For me, I got something which is called as a simplification, but not yet the simplification in the general term of simplification, not to simplify things, but actually these are the things that work behind something simple. So behind something simple, we call it as a call, blah, 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 blah. And the background of process will be the bunch of guys here. So load register with the data, and then after that divided data based on the function, and then after that use the logic of increment and decrement, and so on and so forth. Okay. So what I am trying to say is actually the assembly is, maybe feel you feel it is very hard, very difficult, but actually it is not. If you follow the logic, if you follow through the logic, everything will looks easier. I promise. So these are the overview hardware of 8085. Maybe there is a, what we call as a slide that used to, what is it, explain all those things, but I will explain it carefully for you guys. Okay, there are a lot of things which is included in the hardware of 8085, which is memory, program counter, work registers, condition flags, stock and stock pointer, input output port, and instruction sets. Today we are not going to explain all those things together, but maybe for the pointers, input, and instruction sets, the three in the below, not yet explain it in the event. Maybe I will create the next session in order to explain it in the focus, maybe main explanation for explaining the those three below, yeah, three subjects below, yeah. Okay then, let us continue. So what is actually the memory? Memory is a kind of physical device in a computer system that stores program and data. So we see the CPU registers. CPU registers has a gauge, level 1, level 2, and so on and so forth. We have a RAM, we have a storage storage device types: ROM, removable drive, network, hard drive, and so on and so forth. And then we have input sources: keyboard, mouse, removable, blah blah blah. So this guys here is called temporary storage access areas. Sorry. So this one is the permanent storage areas. So the clue here, what storage that we called as temporary, what storage that we called as permanent, it depends on the how long the data will be saved. If it is long enough, then use this one. If it is not long enough but momentarily data being processed, then you can use the temporary storage areas. So please see the video at Fluent TEDx explained, okay, in the Fluent session. Please find it by yourself. Okay, the difference between RAM and ROM. RAM means random access memory, read-only memory is ROM. And I already told you before that RAM is volatile memory, meaning that whenever there is a unplug of electricity, there is no electricity that flow in the system, then the data will be gone, will be off. In the other hand, if ROM be called as a non-volatile memory, meaning that whenever electricity being electricity being plucked out of the ICs here, then of course the data remain in the storage. Okay, this is the basic difference between RAM and ROM. And the further description is the memory available for the operating system processed to use when is the computer is running. ROM is the memory that comes with your computer that pre-written to hold the instruction for booting up the computer. So this is the basic difference between ROM and RAM. Yeah, you can see by yourself. These are the RAM and the types. Yeah, from the short DIMM until the RDRAM, which is 232 pin RAM. Sorry, pin RIMM. We call it as a RAM bus dynamic RAM. So this is the program counters. We already knew that RAM is just like that. So RAM, ROM, yeah, memory, it is the family of registers. Register just looks like a memory, but register is used for the process of inside the microprocessors. Next, we will see the registers. Okay, first thing first, we need to understand the program counters work. So the program counters keep the track of next instruction byte to be fetched from memory. These are the program counters. So for example, the example instruction in the 0x04 address. So program counter pointing in that address, and then after that, after the execution already done, the output already done, the program counter automatically increment its address into 8 sorry 0x 0 times 0 5. Okay, so the program counters is for hold or for pointing the memories of instructions. So these are the work registers. So basically, the program interpret the work register as a accumulator flags B, C, D, E, and HL. Sorry. These are the work registers. Okay. So registers, as I said in the previous time, it is basically as a what we call it as a memory also, or maybe the storage, in order to help microprocessor process something. Imagine if microprocessor is process the data alone, what will happen? Of course, the data will not been finished on time, right? So we need a helper. So this helper, we call it as a work registers. Okay. So again, please see the position of the work registers. If you see the work register here, just like this, B and C, D and E, H and R, those are pairs. Okay, those are pairs. Those are couple. Okay, do not try to make them break up. Okay, so B and C, because they are working together, so the size of the register will be doubled because each of these register have size 8 bit wide. Okay, if it is being put on together, meaning then meaning that B and C will behold the size of register not 8 byte but 16 byte. It is the magic of having working together. Okay? So remember that microprocessor has 8-bit for bidirectional data bus and 16-bit for the we call it as a address bus. But it is not taboo when you are using 8-bit with your friend until you get 16-bit and to the logic to the process, yeah, to the process as if you have one 16-bit. Remember, please process something and please consider that the overflow. What is actually overflow? Overflow is actually you are not matched with the capacity. I mean, you over a capacity. It is be called as an overflow. Okay, then next. I already told you that there are pairs of register. Yeah, we call that general purpose, temporary, special purpose, 16-bit register. So general purpose, I already told you, P, C, D, E, N, H, and L. So general purpose used to store the data temporarily during the execution of the program. For example, there is no instruction to add the content P and E registers. At least one of the operand has to be in accumulator, thus at B and C registers. So first thing first, move A register content to B register and then add A and E register and then the result will be in A. After that, move the result from A to B registers. These are the how the add function work in assembly, of course. And of course, it is possible to use this three register pair to store 16-bit information. Except only P, C, D, E, and HL can form the register pairs. We cannot force them to form PD, for example, or CL cannot, yeah, because they are destined together. Okay, temporary registers. I already told you temporary. Temporary means not eternal, right? So LU has two inputs. One input is supplied by the accumulator and the other one from the temporary data registers. The programmer cannot access the temporary data register, however, it is eternally used for execution. W and C register are the temporary registers. These registers are used to hold 8-bit data during the execution of some instructions. The registers are not available for the programmer since 8085 microprocessor use it internally. Internally. Okay, these are the special purpose register. I recall the accumulator. Register A is 8-bit register for the arithmetic, logic, load store, and so on and so forth. Okay, so the other function of accumulator is for the buffer, momentarily buffer. For example, if there is a logical operation involving two operands, one operand has to be the accumulators. Also, some other function like complementing decimal adjustment or performed, this use always an accumulator because accumulator is designed as following. Okay, then we are talking about the flag registers. We have numbers of flag registers, which is S stand for the sign flag, Z is zero flag, AC is the auxiliary carry flag, times here meaning that it is not yet, it is not what we call it. It is not used anymore. Okay. P is parity. C, Y is carry flag. Okay. These are the figure number 1.2. So, sign flag. After the execution of arithmetic or logic operators, so the sign flag will be result 1, meaning that given byte, if D7 is 1, the number will be viewed as a negative number. If D7 is 0 here, the number will be considered as a positive number. So sign flag means that it is a flag. It is what we call it? Yeah, flag. It is a sign that the data considered as a negative or positive. Yeah. Zero flag meaning that all the result will is 0. Yeah. Then the flag is active is 1. Auxiliary flag if the D3 or D4, yeah, carry from lower neighbor to higher neighbor, D3 to D4, meaning that auxiliary carry flag will be active. Parity flag is defined by the number ones represent in the accumulator. After the arithmetic or logical operation, it will result in has an even number of ones. So if the parity flag is set, then the parity is odd. Vice versa, if the flag is reset, then the parity is even. Carry flag. This flag is set if there is an overflow out of B7. The flag also serves as a borrow flag for subtraction. In both of examples shown below, the carry flag is set. So for example, this addition, auxiliary carry flag will be 1, carry flag 1, parity 1, subtraction, and so on and so forth. Yeah, you can try to study per yourself. So this is the example again, how to calculate the carry flag. If you have this addition, then you will result this addition is carry. Okay, and this also the auxiliary carry. If there is a P3 to P4 carry, then the auxiliary carry will be 1. If there is a upper nipple 1 here, which is we call as a carry, then the carry flag is 1, the other is 0. So we are finally found about the instruction register. It is type microprocessor operation. The processor first fetch of opcode of instruction from memory, which is it places an address on the address bus and the memory response by placing the data stored at the specified address on the data bus. The CPU store this opcode in register. We call it as instruction registers. This opcode is further sent to the instruction decoder and to select one of the 236 alternatives. So this is the 16-bit registers. Program is sequence of instruction. As mentioned earlier, microprocessors fetch the instruction from the memory and execute them. The program counter is special purpose of register which at a given time store the address of the next instruction to be fetched. The program counter acts as a pointer to the next instruction. How processor increment the program counter depends on the nature of the instruction itself. I already told you about the program counter. For 1 byte instruction, the increment program counter 1 by 1. For 2 byte instruction, increment program counter 2 by 2, or for 3 bytes instruction, increment will be 3, and so on and so forth. So the program counter will be hold 16 bits because it is record the memory. Okay, the stack is reserved area memory in the RAM, while the memory information may be stored. A 16-bit stack pointer is used for hold the address of the most recent entry stack. These are the what we call these are the diagram of microprocessor. I am not currently not gonna explain you all of these things, but I will focus on the particular area, just like this. Okay, this one. These are the, we call it as registers. Okay, register is here. So we have a program counter, as I said previously, 16-bit because it is hold the memory. And the B, C, D, E, and HL are the registers, 8-bit registers, and the data will be transferred in the internal data bus. So the internal data bus is actually the medium, and this one, this guy is right here, this big guy is right here, is responsible for the logic and arithmetic design. Okay, later on we will discuss the detail in the part 2 session, but thank you for your attention. God bless you.